Okay, so we have two integrals on the spot, and yes, they both have the 1 on the top, but the answers are not just going to be natural log of the denominator, natural log of the denominator. No, even though you put the absolute value, still no, because you have to remember, 1 over u, the integral for that, will give us natural log of absolute value of u. But here, you have square root of x. It's different, okay? So don't be addicting to the natural log business, especially you see the 1, right? It's a dangerous addition. Anyway, here we go. I believe in u sub, even though I don't see a lot of things can be cancelled, but seriously, I believe in u sub, so I'll take u to be, perhaps let's just do it with the denominator, 1 minus square root of x. And let me just follow the usual step. I will differentiate both sides. Du and the derivative of this is negative 1 over 2 square root of x dx. And I want to isolate the dx. Let me just multiply this on both sides. So I get dx being negative 2 square root of x, and over there we have that du. And now we can take this integral to the u world. We will see this is the integral 1 over the denominator is u. Du is all this, and keep in mind it's a multiplication, so I will put on multiplying by negative 2 square root of x du. Unfortunately, u and square root of x, they don't cancel out. And the worst thing is that, whatever x right here, it's not invited in the u world. But it's okay, because in fact, we can look back to the original equation and isolate the square root of x. Look at this right here. We know u is equal to 1 minus square root of x. I can just move this to the other side and move the u to the other side. I can get square root of x equals 1 minus u. And I can put this for the square root of x. That would be nice. All right, now let's see. I will put the negative 2 because it's just a constant multiple all the way in the front. Like that. And then the integral, and this is 1 over u. And for the square root of x, I will have to do this, put parentheses 1 minus u. And we are in the u world. That's nice. And now, right here, of course, you can look at this as distribute the 1 over u to the inside, or you can look at this as 1 over u minus u over u, either way. And you will end up with negative 2 integral. This and that is 1 over u. This and that give us minus 1. Put a parentheses, du. We can finally integrate this guy. Now, let's see. Minus 2 all the way in the front. And put down a parentheses for the result integrations because we have two parts. The integral of 1 over u give us ln absolute value of u. Now, this is legit, okay? And then the integral of 1. You have to know which world you are in. You are in the u world. So you do minus u right here. And we are done with the integration step. And we will just put this back for the u, right? And everything will be nice. Now, let's see. We have negative 2 parentheses, natural log absolute value. And the u is 1 minus square root of x. I will have to keep the parentheses because the inside 1 minus square root of x could be negative. So keep it. And then minus the u is 1 minus square root of x. And of course, in the parentheses, another parentheses. So this is pretty much it. You can put on plus c, but perhaps I will distribute the 2. Right? So you just do the usual business, multiply it, do it carefully. And we will have this and that, which is negative 2 ln absolute value 1 minus square root of x. This times that is positive, and you have the 2 times this, which is going to be plus 2. This times all that. Negative times negative is positive times another negative. So it's negative. And you have the 2 square root of x, like this. So you're all done. Right here, you can put plus c. If you want to leave the answer right here, that's okay. But I will label this as c1. Because I notice I have another constant here, namely just a 2. 2 plus c1, you can merge them together. A constant times a constant is just a constant. So you can write this down as, perhaps I'll do this in blue so we can see the difference. It's okay to write the answer as negative 2 ln absolute value 1 minus square root of x. And then just keep the function part. So you have the minus 2 square root of x. But this and that together, you will have to say that's another constant, C2. So just like that. Perhaps I'll box this right here for you guys. But of course, if you leave the answer right here, this is okay as well. Right? But just don't want you guys to fight with other people if they do end up with this answer, and this is how they get it. Constant, constant, another constant is another constant. That's it. And you do this a lot in differential equation, which is coming out soon. Now, let's take a look at the second one. This time, I'm not going to use U substitution because I notice we have 2 square roots in the denominator. Why don't we try to multiply by the conjugate? And it actually will work out really nicely. So let me do that. Multiply this by the conjugate, which is square root of x plus 1. And the middle is plus square root of x. Just like that. Do the same on the top. Square root of x plus 1. And then plus square root of x. So do this first before I do any u whatever, right? Now, let's see. On the top, it's just that. But on the bottom, check this out. This times that, because you have multiplied by the conjugate, all you have to do is the first term square, right? The first term square. So I will just write this down. Square root of x plus 1, you square that, and you minus the second term, you square that. On the top, let me just leave it as how it is. Square root of x plus 1 plus square root of x, like that. This is so nice because this and that cancel, this and that cancel. You just get x plus 1 minus x. And then x minus x cancel. So on the bottom, you pretty much just have 1. That's it. Nothing else, just 1. So when you divide this by 1, doesn't mean, you don't have to worry about the 1. So now you have the integral. This now is much better. I will look at this as parentheses x plus 1 to the 1/2 power. And we add this right here. I will look at that as x to the 1/2 power dx. Here's the deal. If you look at this term, we have inside x plus 1. If you set this to be u, du will be the same as dx because the derivative of x plus 1 is just 1. When you have a constant multiple and you see this right here, you can just do the power rule right away. You don't have to let u equal to this. Anyway, I'll go ahead and do that. So I'll add 1, which is 3/2, divided by the new power, which is 2/3. Likewise here, I add 1, which is 3/2, divided by the new power, which is 2/3, right here. And we're done. I'll write this 2/3 and x plus 1 to the 3/2 power, and we add 2/3 x to the 3/2 power. And if you would like, you can change this back to the square root notation. It's okay. So perhaps I'll do that right here for you guys real quick. This is the same as 2/3. The half power is the same as the square root. And you can write this as x plus 1 to the 3rd power. And you can write this as plus 2/3. Again, look at that as the square root, x to the 3rd power plus c. So they are equivalent, so the c are the same as well. So anyway, up to you. This right here, they are all legitimate. And perhaps some people will be noticing that, hey, you have more power in the square root, so you should factor something out. Yes, if you want to do that, then this right here is 2/3. You take, x plus 1 to the 2nd power in the square root out, which is x plus 1 to the 1st power out, and then you have the square root of x plus 1. Same business. And this right here is just algebra, so I'll leave that to you guys. X square root of x plus c. So I'll do this right here. Yes! Just like that. Let me know which one you guys prefer. Whew, that's it.